This is a quick review of some of the rules for exponents. We'll be adding to this list as we go through our course. The most important thing about exponents is to remember that an exponent means repeated multiplication. So when we see something like -3 to the fourth power, we don't want to get too distracted by what's inside the parentheses. The fourth power is telling us that we need to lay down 4 copies of whatever was in the parentheses, in this case -3, and then we'll multiply those together. The reason to think of it this way is that even if the number inside the parentheses is a positive number or an algebraic expression, we still interpret it the same way. It means write down 4 copies of the expression in parentheses and then multiply them together. So the exponent tells us how many copies to use. So because of that, when we see an expression that could be simplified, like the one that you see here, 2 cubed times 2 to the 5th, we know that 2 cubed is interpreted as laying down 3 copies of 2, and 2 to the 5th can be interpreted as laying down 5 copies of 2, and then multiply them together. So if we do that and we put a times multiplication symbol in the middle, that means that altogether we have laid down 8 copies of 2 multiplied together. And that's exactly what the meaning is of 2 to the 8th. So under that interpretation, the rule makes sense that if we have the same base with 2 exponential expressions, then b to the m times b to the n should be b to the m plus n. In other words, when we multiply powers of the same base, the exponents get added. So let's see what some results of this rule are. First of all, this rule is going to compel us to interpret the exponent 0 in a very specific way. An expression like 4 to the 0, like you see here, is hard to make sense of using the repeated multiplication interpretation, because what does it mean to write down 0 copies of 4 and then multiply all of those numbers together? It's a very strange thing to think about. But if we take this multiplication rule and say, well, this worked fine as long as those expressions corresponded to repeated multiplication, and then think, well, I would like this rule to work all the time. In other words, I'd like this rule to also work in the interpretation where the exponent can be 0. Then we'd have an expression like this. So for example, 4 cubed times 4 to the 0 is an example of our multiplication rule. The base is 4 in each expression. And so the result of that should be 4 to the 3 plus 0. The exponents would be added. But that means that 4 cubed times 4 to the 0 is equal to 4 cubed. And 4 cubed, of course, is, well, it doesn't really matter what it is. It's identical to both left and right-hand side of that equation. But 4 cubed is 64. So 64 is equal to 4 to the 0 times 64. And so the only possible thing that 4 to the 0 can mean in that context is 1. So we consider this our 0 exponent rule, that raising a base b to the 0 power should equal to 1. And mostly, well, not mostly, but one of the reasons we do that is so that the multiplication rule is actually true all the time, even in situations where we can't visualize it exactly as repeated multiplication. Let's see a different way to extend it. Skip too far. If the exponents are allowed to be negative, we have a similar kind of quandary. When you see an expression like 5 to the -2, it makes no sense to say, let's write down -2 copies of 5. So the interpretation of repeated multiplication, again, doesn't make any sense. And so we go back to the same idea we just had, which is, let's take the multiplication rule and extend it so that the exponents are allowed to be negative, and then just see what the interpretation would have to be if that were the case. So the problem I'm suggesting here is we take 5 squared times 5 to the -2. The multiplication rule says that we should have 5 to the sum of those 2 powers. The 2 and -2 would be added if the multiplication rule holds, and that means that would be equal to 5 to the 0. So 5 squared times 5 to the -2 has to equal 1 if the multiplication rule is always true. Well, the word for that is being reciprocals of each other. If the product of 2 numbers is 1, that means that they're reciprocals of each other. Since 5 squared is 25, that means 5 to the -2 needs to be 1 over 25. So if this is 25 and this is 1 over 25, then when you multiply them together, you get 1. And so the more succinct way to write that is what we have here. We can interpret 5 to the -2 as the reciprocal of 5 to the 2, and we're denoting the reciprocal as being 1 over that number. So the negative exponent rule that we generally see written down looks like this. When we have b to a negative exponent, we always interpret that as just 1 over b to the opposite exponent. And that allows us to not ever have to think about exponents, negative exponents, as anything other than reciprocals of numbers that have positive exponents. So let's do one problem for practice. If I'm evaluating -2 to the -3 power, I never want to be too distracted by what's inside the parentheses. As I said before, we are we think about the exponents in the same way regardless of what's inside the parentheses. This is consistent with the PEMDAS rule for operation, order of operations. We are basically saying let's worry about the exponents first. Let's not worry about what's inside the parentheses. Let's understand what the exponent is doing as our first priority. So according to the negative exponent rule, -2 to the -3 is really the same thing as 1 over the same expression but with the positive exponent. And of course we know that a positive exponent can be interpreted as repeated multiplication. So -2 to the +3 is just -2, -2 times -2, 3 copies of -2 multiplied together. Negative times a negative times a negative will be a negative number, and 2 times 2 times 2 is 8. So I have 1 over -8 as my answer.